Hello, everyone. Thank you for joining our webinar today, Label Claim and Adulteration Testing for Dietary Supplements. I'm excited to have Han Yu here with me today hosting the webinar. I am Amy Knock and I will be moderating today's session. Before we begin, I wanted to let you know a little bit more about how the webinar will run. The webinar is being recorded and the slides and recording will be available for you within 3 business days. A short Q&A session will follow the presentation today to answer any viewer-submitted questions that you might have. During the webinar, you can submit questions you have using the webinar sidebar menu. Select the Questions tab, type in your question, then hit the Enter key on your keyboard. Remember, you can submit questions anytime throughout the webinar. That concludes my very brief introduction today. Hong, I will now pass it over to you.
Thank you so much for the introduction, Amy. Good morning, everyone. It's such a great pleasure for me to be here today to talk a little bit about label claim and adulteration testing for dietary supplement, which is actually one of my favorite topics. I'll briefly go over some concepts, definitions, regulations, as well as practices and research that we have conducted at Eurofins. If you have any specific questions, like Amy said, I'm happy to answer them later. I'd love to start this presentation by giving a little bit background information about who we are and what we do. So Eurofins is the global leader in testing, inspection, and certification industry. We have over 55,000 employees, over 900 laboratories across 50 countries. And we are conducting over 450 million tests every year. As you can see from this map, our US food division has about 50 laboratories across different regions all over the country. Our expertise covers a wide range of categories, including microbiology, nutrition, dietary supplement, contaminants, dairy, specialty, and product design. According to a recent report that CDC published last year, among all adults from 2007 through 2018, age-adjusted dietary supplement use increased from 48% to 56%. For all age groups, dietary supplement use increased significantly. In a different survey conducted by the Council for Responsible Nutrition, as high as 77% of US adults take dietary supplements. So it's a booming industry. Among all types of dietary supplements, herbals and botanical categories has one of the highest growth rate, with 50% of total supplement users taking botanical products. This category has grown by 19% points since 2015. Popular ingredients such as green tea, turmeric, as well as CBD extracted from cannabis plant have been leading this trend. This is a webinar of series on food fraud and adulteration. So I think there may be participants who came from the food discipline. So I would love to clarify some of the terms that look confusing to the public. Dietary ingredient is a vitamin, mineral, amino acid, herb, or other botanical. They are dietary substance for use by people to supplement the diet by increasing the total dietary intake. It can also be a concentrate, metabolite, constituent, extract, or a combination of those substances. Dietary supplement is the finished product form that contains dietary ingredients. It's classified as a special category under food, and is using a different set of regulations than conventional food. The existing regulatory framework for functional food is the same framework that applies to food in general. The ingredients used in functional food, including dietary ingredients, are regulated by the FDA. There is no nutraceutical in the US federal law. If you do see this term appearing in some products, they are either foreign products or they are illegal in the US. However, you can see this term in some international or scientific communities, such as IFT. In those contexts, usually nutraceutical means a combination of both dietary supplement and functional food. So from the regulation standpoint, the production of dietary supplement follows 21 CFR 111 cGMP regulation, and the labeling rules of dietary supplement follows 21 CFR 101 food labeling regulation. So it's still a food. Dietary supplements are not intended to treat, diagnose, cure, or alleviate the effects of diseases. Therefore, the US law have strict requirement on what type of claims that you can use on the dietary supplement labels. There are three categories of food and dietary supplement claims that are defined by the FDA regulations: health claims, structure function claims, and nutrient content claims. So the health claims describe a relationship between a food component or a dietary supplement ingredient and reduce the risk of a disease or a health-related condition. FDA authorized this type of health claims based on an extensive review of scientific literature. On the other hand, structure function claims describes the role of a nutrient or a dietary ingredient intended to affect the structure or function in humans. Structure function claims do not require the pre-approval by FDA, but they require to include a disclaimer, like here, to show that these statements have not been evaluated by the FDA. The nutrient content claims characterizes the level of a nutrient in a dietary supplement and describes the level of a nutrient in the product using terms such as free, high, low, or high potency, or antioxidant, and something else. Because nutrient content claims are related to the concentration and identity of nutrient, a supplement fact panel is required. So from the label statement standpoint, there are 5 statements that are required on the containers and packages of dietary supplements: the name of the dietary supplement, the net quantity of content, the nutrition labeling, the ingredient list, and the name and place of the manufacturer. So among the 5 required statements, the nutrition labeling and the ingredient list are shown in the supplement fact panel. The nutrients name, their levels, and sometimes the percentage daily value are listed in the upper part, and the ingredient list is often in the lower part to show the dietary ingredients as well as other ingredients, such as excipients, fillers, colorants, sweeteners, flavors. The value of the nutrient level, the identity of and the authenticity of listed ingredient, and the contaminants behind the scene all need verification testing. The 21 CFR 11170 cGMP regulation asks to establish specifications for each component used in the dietary supplement manufacture for their identity, purity, strength, composition, and limits on contamination. It also asks to establish label specifications for dietary supplement. In 21 CFR 11173, FDA requires you to determine the specification that you established. And in the 21 CFR 11175, they ask to conduct at least one test to verify the identity of each dietary ingredient. They also ask you to use tests and examinations to verify that your dietary supplement finished product meets those specifications. So it's all about specification. So what does a specification look like? Here is an example of ingredient specification for standardized Tongkai Ali extract dry powder. It's not the best specification that I've seen, but it contains all the basic and necessary information. For example, if a dietary supplement manufacturer chooses to add this ingredient in their product, they would know that this ingredient contains Eurofins for over 2% by weight, and the test method was performed using an HPLC. It's also indicated that the ingredient producer used the HPLC method to test the identity of tonka ali. So usually the value listed in label specification is lower or equal to a finished product or ingredients specification. This is because FDA allows some room of error for amount that you declare on the label due to variability of analytical method or naturally occurring nutrient. FDA has its own definition of dietary supplement adulteration, which has a wider scope and is different than the adulteration definition from the common sense. So FDA defines a dietary supplement to be adulterated if it has been prepared, packed, or held under conditions that do not meet cGMP, meaning if you violate the regulation, your product is adulterated. The common sense adulteration is closer to a definition that US Pharmacopoeia or American Botanical Council used for the economically motivated adulteration, which means they intentionally do something illegal to increase their profit margin. For example, they may use substitute ingredients or diluted ingredient, or they may add active pharmaceutical ingredient to achieve some goals. There are also unintentional adulteration. For example, the product may be contaminated by some allergens, E. coli, or GMOs if they claim to be organic. In some other cases, they may not know what they don't know and made their active component degrade or interacted with other chemicals. However, no matter if it's intentional or unintentional, your products are adulterated if they do not meet the specification you made. Dietary supplement regulation cGMP was started to be fully implemented since 2010 for all size companies. For the last 10 years, more than 50% of the FDA warning letters for dietary supplement listed specification and testing being the reasons for adulteration. Analytical testing is an important and most times inevitable way to ensure your product meets specification. So according to NIH database, there are thousands of different dietary supplement products with different formulations. To alleviate the burden on testing, FDA has been creative and asked to use scientifically valid method to conduct dietary supplement testing. The subpart E of the regulation asks to confirm your testing methods are scientifically valid, and the subpart J also called out to use scientifically valid method for specification testing. Comparing to a full method validation, scientifically valid methods primarily ensure the specificity, accuracy, and precision of the method. Until today, a great amount of people still think pharmaceutical industry is highly regulated, while dietary supplement is in a place where it's so easy to live. The fact is probably different, at least from the quality control testing perspective. Taking a botanical supplement testing as an example, the analytical scientist needs to take a lot of factors into consideration. For example, the same golden seal species may have different alkaloid contents when they were grown in different regions. And ashwagandha root contains a completely different visanolide profile than ashwagandha leaf. However, if these ingredients are listed correctly and honestly on their specification and label, you cannot produce a fake negative identification testing result and fail them. Therefore, running fit for purpose and scientifically valid methods becomes the key. So we need to test for identity, strength, purity, composition, and contaminants for dietary supplement and label specifications. How do we do them exactly, and what do they mean? The identity testing is to answer a simple but not easy question, such as, is your green tea extract a green tea extract? Depending on the actual scenario, different methodologies may be chosen to use. You can smell, you can look at the color, but normally you will want to use a more specific testing to enhance your confidence, especially for the ingredients that have been highly processed. Chemistry testing is easier to be standardized. For botanical identification, FDA requires to list the exact plant part that's used in the formulation. So TLC and HPLC are the most frequently used method, and they are well recognized by the US pharmacopoeia. But DNA-related technologies such as PCR-based barcoding and next-generation sequencing become also popular in recent years. Each technology has its obvious pros and cons. Therefore, running multiple tests to conduct an orthogonal approach is necessary. It's necessary in some cases. Eurofins laboratories have been using a variety of analytical methods to help our client meet their identity regulation requirements. On the left side of the slide, our scientists distinguished Maravilla raspberry from common raspberry by using HPLC to determine some special anthocyanins that Maravilla has higher concentrations of. And on the right side of the slide, HPLC was used to distinguish true cinnamon from cassia cinnamon by demonstrating the band differences between lane 2 and lane 3, with lane 2 here being the true cinnamon and the lane 3 being the cassia cinnamon adulterate. And in this example, the client has 3 true cinnamon samples. They believe it's the true cinnamon samples from lane 4 to lane 6. But they showed the presence of cassia cinnamon as an adulterant under the shortwave UV light. You can find the cassia cinnamon's signature band around 0.35 retention factor. It can be seen in these samples. So in another example, you can see that the peanut skin ingredient contains some extra bands that a grapeseed extract doesn't have. You can see that this is a peanut skin extract, and this is a grapeseed. So if you replace a grapeseed ingredient with a significant amount of peanut skin at a cheaper price, you may be able to fool some non-specific UV spectrophotometer method, but it will fail HPLC. In another example, you can clearly find a big methanol yellow synthetic colorant peak right here in this turmeric chromatogram. This type of adulterated product are circulating in the market, and you can only find them out by testing them using the fit for purpose and scientifically valid method. This is a study paper that we co-authored with American Botanical Council to test the identity of elderberry. With 532 products being tested in 2010, 58 of them were found to be adulterated or failed the identification testing. By using HPLC methodology alone, the failing rate is less than 10%. But when both HPLC and HPLC tests are used, the failing rate increased significantly to 45%. So we can probably speculate maybe one of the reasons is, the HPLC alone produced some fake negative result. So in this HPLC chromatogram, lane 1 and 2 are authentic elderberry, and 3 to 6 are commercial samples. It's a little bit different to say. It's a little bit difficult to say if these products contain non-elderberry material or not. So they may get a pass by just using HPLC. So it's a fake positive result. But in this HPLC chromatogram, where the above is elderberry and the bottom is black rice adulterant, we can find that the black rice adulterant doesn't contain some unique anthocyanin peaks that the elderberry has. From the chromatogram, you can see the first two elderberry anthocyanin peaks cannot be found in black rice. And black rice also contains a small anthocyanin that the elderberry doesn't have. Therefore, the black rice adulterant can be identified in this way. The strength potency is the concentration of the ingredient, so each item should be listed on the label. Usually, chemistry methods are carefully developed and verified to test the strength and potency claim. When there are analytical methods available, you will be expected to use testing to verify your label. Occasionally, you can exempt testing requirements and justify the strength potency level by the input level. So in this example, the manufacturer listed their levels of rose hips and echinacea, like this one, just the input level. But in most cases, the manufacturer, they choose to label both weight and the marker compounds level. For example, this one contains 250 green tea extract, including 135 milligram of EGCG. And if you listed 135 of EGCG and test result becomes like 100 milligram, then you are selling an adulterated product. Eurofins has never stopped its investment on developing new analytical methods for the industry. Recently, my team collaborated with reference standard manufacturer Chromatographic and the column manufacturer Phenomenex and published a new stevia-side potency method on the Journal of Agricultural and Food Chemistry. It shortened the separation time from 80 minutes to 14 minutes, and it can simultaneously determine 13 Ribaudiol site sweeteners without using the expensive UPLC or mass spec. This is particularly important because most of the stevia growers are in developing countries, and the instrument accessibility would be an issue for them. So based on this method and a few other methods, we later worked with international stevia council member companies to develop a new international industrial standard that has been adopted by the JACFA last year as its stevia monograph. In another example, the cocoa flavanol and the procyanidin analysis has always been challenging because its chemical complexity and lack of reference standard. In a recent AOAC cocoa flavanol 2020.05 method that Mars led to develop, we worked together to qualify a new NIST reference material to be used as the calibration reference standard for cocoa flavanol quantification. So after that, we worked with Mars to complete an AOAC multi-lab validation study for this LTF-LD method and successfully validated and developed, deployed this AOAC method in Eurofins, US, Germany, and China labs. So comparing to identity and potency testing, the purity testing of dietary supplement has a different focus, and it targets on the portion of percentage of a dietary supplement that represents the intended product. So sometimes it's as straightforward as to find if your product contains a dead fly, for example. But most of the cases, Eurofins test those foreign materials using microscope followed by tools such as FTIR or ICP-MS and other instruments, depending on the details of the material. To test the small amount of unwanted impurities in highly refined ingredient, the purity testing sometimes can be combined in the same method that's used for potency and strength. For compositional testing, we often need to test, for example, the strength of the tablet or the homogeneity of a liquid using special instrumentations. Eurofins is well set up to meet all type of compositional testing that pharmacopoeia code out. The contaminant testing, such as heavy metals, pesticides, and residual solvents, are necessary per the FDA. So usually their testing methodologies and pass-fail criteria are more standardized by the regulation. Recently, we started to see more requests coming in for active pharmaceutical ingredients. So this is the Amazon requirement that they require all the sexual enhancement products and weight loss dietary supplement to test for this active pharmaceutical ingredient as adulterants. This showed that the market influencers such as Amazon begin to pay more attention to the economically motivated adulteration and consumers' health. And Eurofins is well set up to conduct all of these testings. There are also other types of terms that you can find on food and dietary supplement labels, and the FDA has provided its opinions and guidelines about these terms on their website. Although FDA has not fully defined these terms and is still collecting the public opinions to assess them, there are different testing strategies for these claims. For example, Eurofins can conduct pesticides and GMO testing to support the organic claim. So FDA has considered the term natural to mean that nothing artificial or synthetic has been included in or has been added to food that would not normally expected to be in that food. For a recent research study that we conducted for natural claim testing, we collaborated with Beta Analyticals and the Trust Transparency Center and found that using the carbon-14 accelerator mass spectrometry method alone cannot determine which constituent contains the synthetic compound that's derived from petroleum-based material, whereas using a method with HPLC alone can only provide indirect evidence of curcuminoid's natural origin. So by using both methods to test commercial turmeric dietary supplements that claim all natural ingredients, we found only 4 out of 14 samples supported authentic label claims, and a significant correlation between the percentage of curcumin to curcuminoids and the percentage bio-based carbon indicated that the synthetic curcumin was greatly contributed to the synthetic ingredients that's found in this testing. So this is an organic orthogonal approach, and this study has been just published by a top-class academic journal, Food Chemistry. So here are some take-home messages. Dietary supplement is regulated in a special category of food and follows the food labeling rules. Specification violation is the top reason for dietary supplement adulteration, and testing is necessary to verify these specifications. So when you think about adulteration, don't just think the economically motivated adulteration. Anything that violates specifications and FDA regulations in the dietary supplement production is an adulteration. So it's so important to use scientifically valid analytical methods and fit-for-purpose methods to test the identity, strength, purity, composition, and contaminations of the dietary supplements. With that, I want to thank you for your participation, and I'm ready to take some questions.
Thanks so much, Hong, for your presentation. And at this time, I'm just going to add a poll here. Again, would like to ask if you would like someone to follow up with you after the webinar, just go ahead and select the yes option and we will follow up. All right, so moving into the questions here. Hong, the first question that came in is, what do you do if you find an adulterated product during your testing?
Yeah, so it's a good question. We often communicate with our client first. So when we do testing and we found a suspicious result, that's from the potency testing standpoint, if it's low, then it's adulterated, right? So we issue the CFA to our client, and in a lot of cases, we communicated with them to say, hey, your result is low. And the client often find it out by themselves as well. So they reach out to us and ask, hey, what's going on here? Why it's low? We thought it should be high, or we tested it in our laboratory and it's meeting the spec. Why your result is low? And then we have a service called out of specification investigation. So once we trigger that, we do some retest. We have our senior technical lead to review all the testing procedures and double check if we use the correct method, or if we help the client review their method, their specification. We work together to confirm if this is a true adulteration cases. And for the identity testing, as I previously showed if we find, for example, an adulterate peak in the HPLC chromatogram, we before we issue a CFA, we reach out to the client and tell them, hey, this is what we found, and we want to work with you to confirm there is a true adulteration, or we conduct orthogonal testing using a different technology and to confirm the finding.
Perfect, thank you. Next question here. What is the most important performance characteristic that you need to pay attention to during the method development for a dietary supplement?
Yeah, that's a good question too. So it's tricky, right? So as I mentioned before, there are quite a few method performance characteristics that you have to test. So in my opinion, the specificity is the most important one, or it's the first one we need to test before doing anything else. That's because if the specificity testing is not accurate, then all the result is wrong. So if your peak is not pure, if you didn't separate it out, or you thought is caffeine, but it's actually not caffeine, then there is specificity problem. And if there is any specificity problem, all the later data, they are useless. So that's why in the method development, we always focus on specificity first.
Okay, great. Thank you. I'm just getting caught up on the questions here. The next one comes in, is there a regulatory document that provides clear guidance on the routine QC testing that should be performed for each manufactured lot of dietary supplements?
As far as I know, I don't think so. So there are pieces of information here and there to say what you need to do in detail in terms of testing. That's why we, as a contract lab, we provide consulting and help here. So it will take some time to figure out what really make the thing work and how to integrate the testing program into your quality control system seamlessly, because you don't want to test too much and you don't want to test too little. So we of course recommend you work closely with your contract lab, and hopefully it's Eurofins, and we will work together to figure this out.
Great, thank you, Hong. Next question here, is dissolution or drug release ever required for dietary supplements?
As far as I know, they are not required. So drug release, to my understanding, is that like a dissolution testing or something like that? If that's the case, I think it's if you, for example, if you follow USP, if you want to claim like my product is USP grade, then USP uh, for some product they have the dissolution testing listed like a release, more like a time released study that you need to follow per the USP. But if you don't claim USP, you just want to follow the very basic, very minimum requirement. I personally, I don't think it's required, but I will suggest you to reach out to a professional consultant to confirm this.
Great, thank you. Next question, if there is not a monograph for the active raw material, what types of testing should be included to release it for manufacturing?
So that's a good question. So for on the FDA's regulation, it clearly said if there is AOAC method available, you have to use it. And I think that also covers like pharmacopoeia, for example. Like if there is such thing available, you have to do the testing. You cannot say, oh, there is no method available, I cannot do it. You have to do the testing. But you don't have to use AOAC or pharmacopoeia method to do testing. As long as you use a scientifically valid method and you have the justification there, then it's fine. But there is also a different set of regulation to tell you how to exempt testing. So you need to collect a lot of evidence to say there is no such reliable method available anywhere. And it's better to, this statement is better to be supported by some supporting materials to say, for example, if you are selling like, let's just hypothetically say ashwagandha leaf, you want to sell it, and then you want to exempt testing, you don't want to do the testing, or there's no way to do the testing, then you have to find a lot of documents to say I find a lot of contract labs, I find AOAC, I go to check pharmacopoeia, there's just no such method available. Then you can use the batch record or input level for your label.
Great, thank you. Next question is, can you help with setting limits for dietary supplement testing? For example, how do we set sodium limits in a dietary supplement with regard to class 1 and class 2 requirements in 21 CFR 101.9?
Oh, yeah. I think we can assist the clients to do those, but we cannot take the liability and determine those things. So like for sodium testing, we have like our Des Moines lab or medicine lab. They do that all the time, and I would suggest you to reach out to our technical experts there to ask about these questions. But it's we are doing testing, not so much on the regulation side. So usually we take a sample, we tell you how much sodium it has on your product, and you have to figure out from the regulation terms or from your legal consulting to say if this is the correct limit to claim like low sodium or sodium free or something like that. Eurofins usually does not take those type of liability, from my understanding.
Great, thanks, Hong. And I think we have time for one more question. I'm just getting caught up on the ones that have come in. This last one here, what gaps or bottlenecks have you identified in terms of current technology to address the identification of adulteration? And what are your thoughts on non-targeted techniques?
Yeah, so that's a great question. So the gap, I think is pretty obvious if you in this industry long enough is for identity testing is not easy to have a one-stop shop. So especially for the blend with a lot of different stuff in there. It can be botanical stuff. It can be some other dietary ingredient, or even excipients, or the encapsulation, or different forms like liquid capsule or something like that. So it becomes quite complicated. And if you want to do a very easy identification testing, you have to, I mean, it's basically impossible if in those type of complicated material. So, and if you use non-targeted method, for example, you have let's still take ashwagandha as an example. If you have ashwagandha ingredient, but it's in a 30 botanical blend encapsulated in oil capsule, then your non-targeted method can only be established on this specific type of product. So you use let's say a FTIR, or you use an NMR, or some other spectrophotometer, to establish the non-targeted method on this particular formulation. That's fine, but I rarely see people do that. Just because you spend a lot of resource efforts, you bought the high resolution mass spec like $600,000. You use that to just to establish a model on a very specific matrix, and that cannot be applied to other matrices. So economically, it doesn't make sense. That's why there are so many non-targeted method discussion in the academia, because I mean they are focused study, right? They can do that, they can afford that. But in the industrial setting, it's each company has like 100 products, and it's so difficult to use non-targeted method in that way. So I think that's the current gap.
Great, thank you, Hong. And it looks like we are caught up with the questions. In case that there are any that we did miss, I certainly will follow up on those, have Hong follow up with you. But that wraps up our Q&A session. There also were a lot of questions that did come in the chat today about receiving a copy of the recording. So just a reminder that you will receive a copy of the slide deck as well as this recording within 3 business days. So we will send that out to you. Be sure to check your inbox for that. And again, thank you, Hong, again, for your expertise and your presentation today. And thank you, everyone, for attending.
Thank you, everyone. Bye.
Thank you. Bye.